Hey everyone, welcome back to my workbench. So, I do have some 5200 orders in queue, but in the meantime, I wanted to spend a day or so working on the Intellivision controller, my True 16. So, turns out, there's a little, I wouldn't call it, oh, well here's the problem. I was going off of some technical data, the pinouts from Jay Tilton. This is great, he did the work. But this is from 1998. So this is 27 years old. So when I went to hook up my controller, it's a gosh darn rat's nest right now inside because this is the prototype. There's the guts of it right now. I discovered that when I have it all wired up, direction control works okay, buttons so-so, but the keypad, no bueno. I have found one problem. I flipped my rows in my order, fixed that, that was fine. Electrically I measured out, works great. And still the Intellivision doesn't want to recognize it. It's like, why the heck don't you recognize it? So I started doing some little more basic research. Because I like using my own research for this stuff. So, great work, good starting point. However, no mention of the small fact that the original controller, compared to modern controllers, ooh, bumped my camera there. Original controllers, which is one of them, this one's Intellivision II, much higher resistances than we find in a modern controller. Like mine, when you ohm it out, I mean, less than an ohm, less than an ohm, less than an ohm, less than an ohm. All these are less than an ohm, and even the keypad's like, I don't know, 1-2K tops. Even less than that because it uses snap domes, and so very low resistances. This sucker, on the other hand, 500 ohms, all directions. For some reason, this column is quite high. It's something like oh, I gotta remeasure it, but it's like 700K or something crazy like that. And then these columns are different, and the rows are different. So I think I'm gonna have to put in some current limiting resistors, because that must be how it was intended. Because I don't think the Intellivision quite understands. Like, I think like on the modern buttons, when I press it, and same thing with the side buttons here. The side buttons are the same way. They're in the multi-K range. No matter how hard you press on these buttons, that's the most you get. So they must have built-in current limiting resistors. Let me see if I got a crappy one over here. This is a television controller. I've never actually taken one apart. It looks like a toolless design by the look of it. I wonder if I can get it with a spudger. So all I'm going to do tonight is probably make a... Someone else tried to get into it too. I could see the plastic janked up. That wasn't me, so I never taken one of these apart. I'm willing to bet that what's happening is they put some current limit in there to not freak out the... I think I'm just pulling the 5-volt lines too low. I'm going in here. Could be wrong. Or they use it for like some sort of easier differentiation. But my guess is I'm just going to have to throw some, just some current limiting in there. Oh, how do you open up, little guy? Let's try the guitar pick. Not that it matters, I'm going to measure it electrically outside anyway. one more try. Looks like goes in this way. I don't like snap fit. I don't like snap fit. I like screws. Whatever. You know. Meantime, I'm not gonna mess around with that too much. It's off to some basic research here. This is how it's gonna work. Is I have the breadboard here. First things first, I need to make up some cables. I'm going to wire them the same color I'm using internally on my system to make it easier. One side's going to be real easy because I'm just using IDC. So yeah, I'm going off some pretty old research. I'm buying more cable coming in the mail tomorrow anyway. Starting on red, ending on black. So now that's what happens when you don't do your own research on the 5200. That's what I did. I had some minor hints from someone was making made a theoretical analog controller using the digital potentiometers along with a capacitor, which is what keyed me on the fact I need probably a little capacitance, and I did, but totally different value than what they had. But it has to do with the span of the potentiometer anyway. So that's neither here nor there. But in this case, like I said, it's 27-year-old. I mean, good information. It's all correct. It just they didn't mention that no one they didn't look at the internal resistances of the controller itself. So once I get this figured out, I'll be able to release it. I think Mitchell jinxed me. So I was like, okay, I'm just going to plug it in. Everything's wired right. I checked it all, like, electrically, and it's like, son of a bee. Really? Well, live and learn. This is not insurmountable. The logic, though, all matches. And I was doing some just hanging a pin in there logic. It's a pain in the butt. That's why I'm building this thing up. So I'm going to spend a little time tonight doing this, and then tomorrow's Easter, so I need to actually, I got way too many orders over there. I got 4 controller orders right now. So it's a bit. Thank you everyone for all your orders. I just did a fresh 3D print on some knobs, and that's coming along nicely. Okay, so this one's going to be from this guy here, and then this guy is just going to be a straight up IDC, so I don't need to worry about crimping you. Yeah, I was just figuring out my cost for my controllers for parts, because the wonderful tariffs are getting rid of the, there used to be a minimus, which was if it was below $800, they don't tariff it. They're taking that away, which is also great for us small business owners who are not going to have to pay 120% tariff on everything. So luckily I bought a lot of parts ahead of time, except for a few of the internal components, so we should be able to weather a while before I have to do any price increases. But when it happens, I'm going to just add it to the price of the controllers. So there's a little inside baseball, like a standard where's my tool? Oh, right in front of me. There's a little inside baseball, like on a regular like overlay controller. It's like $41 in parts around there, plus quite a bit of labor. Most of the about $36 of the parts are imported, and like $4 are from domestic. So assembled in USA of all sorts of parts. So, not great if you were a small business and you really could use some inexpensive parts from China. And the big businesses are even worse. They're like 240% right now, or something just like insane. So I hope everyone enjoyed their Temu, Shein, and AliExpress orders, because you're going to be paying tariffs if they ship it with postal service. It's $100 regardless. That's insane. So it's nuts. So if you see small businesses start disappearing, you know why. Frankly, illegal tariffs, in my opinion. Congress has the right to make tariffs, not the president. But it doesn't matter anymore. There are no rules. Yeah, I try not to get too political, but this is like, for me personally, is just like, I mean, I can weather it, and luckily, but I mean, don't be shocked if my controllers go up $40-50. And like the dual sticks and the Andy controllers, those will go up probably 60 when all the tariffs fully hit and I run out of parts. I mean, luckily, I bought a lot of parts ahead of time, so I've got about 5 months in parts on most of it. So my usual burn rate. So, but still, it's like, why are we doing this? No one wins in trade wars. Bad for competition. It's bad for free market. It's just bad. And for giggles, I went through and if I had to make a controller out of all US made components, what was it? It was like 750 in parts, around that. So I don't think the market would bear $1,000 controller right now. Yeah, it's rough. And I don't know what's going to happen. I mean, what's it going to be? 400%, 1,000% blockades? I don't know. And it's like a lot of these things, like I can't even source them, like the analog joystick part. I mean, I probably have to end up like manufacturing it myself. I don't know how much that would cost. That'd be a pain. I'd have to design it, print it. It's never going to be as good as an injection molded part. If I had to do like a small run injection mold, I'm talking thousands of dollars in tooling. It's like ridiculous. This is a hobby. This isn't my day job here. Even my day job, oh my goodness. We basically can't order anything from China. Nothing. Sheet metal, wheels, you name it. PC boards. And I got to switch to all domestic or North American suppliers. But who knows how long that's going to last. It's just crazy. It's madness. I don't know who this is supposed to serve. Enough of my ranting here. So I'm just making up some cables here. Tin these so I can actually put them in the board. I went to the Museum of Science and Industry today. Well, the Griffin Museum of Science and Industry now, I guess, is the new name of it. Chicago Museum of Science and Industry didn't have a name like a family name associated with it forever until like 2 years ago, I think. But that being said, the upkeep's been pretty good. I'll have to give them that. You can see that a lot of new exhibits, a lot of stuff that's not like left over from like the 50s and 60s, or a bunch of 80s stuff. So I hate to say it, but it's not bad. Alright, for anyone get into electronics, Experimenter's perf board, ever wonder how these work, is I'll turn it. You have the center section here is all rows, so these are all bussed together. So like 10, 11, 12, these are all bussed, and then the columns here, columns and the rows here, they're usually labeled plus minus like this one. These, you have continuity here, and then you got a jumper here, but I'm not doing anything that fancy. I'm just going to put it in the order I have it on in my controller. So let's just start on. Skip because you go down a row. IDC is weird to get because it jumps down a row. Yellow. Red, yellow, blue. So I'm going to plug one end of the controller. Well, initially I'll just plug in a controller and I'll show you the difference between them. And then I will go blue, gray. And then I'll compare it against my controller and you can really see a difference. Gray and black. Black's the ground. Put you in one row here. I put it in there. Then we skip back to orange. I have a second monitor set up by off my left shoulder. Orange, green. And then green. Violet. White. So I got that coming off of there. Now I need the plug side. Yeah, so I went to the museum today. It was nice. We got to some brought a friend with. That's kind of cool. So that's on the right. So these are, you can see that working on here. These are little, this one says little solder cups in here. I might grab a vise. Let me see. Sometimes these like to skitter away, but this one isn't too bad. So yeah, once I figure out the rows and columns on this thing and the buttons, what kind of resistance it's expecting, I can't find my fume extractor. It's driving me nuts. It's gotta be in my office somewhere. Found my lithium pack welder, but I can't find my I can't find that. Helping hands, maybe. There's a handy tool. Helping hands. goggles activate. This is too long. Okay. Not that much strip. Don't need much. Yeah, I got to see, walked around the U505. That was cool. It was the only Type 9C German Unterwasserboot that is in existence right now, which was the terror of the North Atlantic. I never realized they captured it right off of the coast of Africa. So they did is they captured it and they towed it all the way to Bermuda. And in violation of the Geneva Convention, which is kind of unavoidable, they did not let the families know that the crew was still alive. Because it was like top secret. Because they knew if the Germans knew if the submarine was captured, they would change all of their code books. And they did not. So they found out a few months after the war, they came back to Germany alive and well. I think they kept him in a prison camp in Louisiana. Yeah. I was like, this is interesting. Didn't get to tour it this time. I think next time you can go through the U505. You can see all the shell holes from the 50 cal machine guns and the small caliber shells in the conning tower. Pretty amazing piece of history there. Of course, it did horrible things and sank thousands of ships, but that is war, unfortunately. So I went through and I'm gonna make sure all these solder cups are filled with solder. 22 minutes. I'm trying to keep my videos less than half an hour. It just gets a little long. But luckily, I mean, after I get this set up, I'll take some measurements, figure out what I have to do in terms of adding some, where I need to add some resistors. I know I need to add like a 500-ish ohms to the direction pad, which is my joystick, which makes sense to limit that current flow, and then some, I don't know if I'm going to go all the way resistance wise, but I might have to dial in with a pot and see if I need to be that high on some of those. I don't know if they did it specifically or if it's just a matter that the contacts have oxidation on it. Might be a little from column A, a little from column B. This is not my most beautiful work, but here it is. I'll flip it over in a second and go their way. Yeah, they also have the neat, I haven't seen the body slices. They're like from like 1920s or 1930s. They took body donors' body, at least two different people. It was one man, one woman at least, maybe a little more than that, and they sliced them in different directions. Interesting seeing how we're actually made and how much we just look like a bunch of meat inside. It's kind of creepy, actually. Looks kind of like pork. And the creepiest of all is they have the human embryos from like 6 days, a 6-day embryo up to a 37 week at various weeks. Crazy. Boy, humans are tiny up until about the 8th or 9th week. Just tiny little specks. It's crazy. And then you grow fast. Yeah, the main limit to viability is the lungs. Yeah, I think you have to be like at least 24 weeks, somewhere in there. Maybe a little longer before you can actually like use your lungs to exchange oxygen. They don't get that capability till later. Oh, that looks like crap. I'll redo that one. Yes, it's going to be problematic there. I think last time I mentioned there were families taking up archery. I actually went out and I got myself a new bow and shot the other day. It's a lot of fun. I forget how fun archery was. I was talking to my psychiatrist because I have anxiety, depression, and ADD, and she didn't know what archery was. I was like, oh, that's interesting. I didn't think it was that exotic. Alright. Not too much longer. Maybe I can demonstrate at least one of these. Strip this a little longer this time. I'm actually looking forward to getting this Intellivision working. I was trying to play Burger Time. It was funny because I was able to the joysticks and buttons seemed to work, so I was able to start the game with my original controller. Then I switched over to the True 16, and it played fine. It was great. Burger Time is like a really like directional game, and oh my goodness, that original controller is like, oh, what were they thinking back in the 80s? Between the Intellivision, the ColecoVision, and the 5200, Atari 5200, it's like, oh, what ergonomic nightmare happened back then? Even compare it to like the original 26 Atari VCS, the 2600, just how wonderful and elegantly simple that. It's not the best controller on earth, but at least it worked. And the ergonomics weren't completely horrible, though I preferred the TAC-2, the Totally Accurate Controller. That was my favorite joystick. It had the classic ball-style arcade stick. Nice rounded corners, you could play it for hours. I beat Pitfall 2 with that controller, remember that. I got really far in Reactor. I love the 2600 version of Reactor more than the arcade version. That's a great version of Reactor. Keystone Capers. Oink, that's another good one. The Activision had a lot of great games. Like their Fishing Derby. And then you have like the original Atari games like Atari Bowling, Combat. That was a good packing game, Combat. Pac-Man was terrible, but the Combat was actually really fun. And then, other games? Yeah. Those are the main ones. Oh, Atlantis, that was a good one. Demons and Dragons. I never played Space Ark. I should fire up an emulator one of these days and play that. Yeah, there's a lot of good playable games. Sword Quest. Earthworld, Fire. I don't know if they finished the whole series off there. That was a challenging game. It was a big game. It wasn't like a Tunnel Runner. That was crazy. It was like a first person. It was like a proto first person shooter kind of thing. But you didn't get to shoot. You just ran around this maze, hoping you didn't get killed. I'm doing now is putting the wires into the same columns. Hopefully. If I didn't put solder on there. And I'll be able to probe in here and I can show everyone what's going on with the original controller. And then I'll be able to also plug into the kind of jumper through it so I can spy on the voltage levels coming off this thing. Oh. Grandpa's hands are getting tired. Black. It's definitely not a diode drop because I did the there's no diodes in the controller. As I flip you can put your meter in diode mode and you flip it around to see if it's actually in diode mode. You'll see either like a 0.3 volt or a 0.7 volt depending if it's silicon and germanium. I could have freaking pronounce that word. Germanium diode. Voltage drops are different, but you can tell what your cathode and your anode are. I'll show people what I mean in a minute. Alright, so this is all wired up. The main one I need to worry about right now is where's my DuPonts? I got a bunch of DuPonts over here. Alright. I just bought this as a kit. Male to female. Male to male. Some there. If I don't have enough, I can always build my own. More red mail there. Ooh, that's cool. I got the DuPont to an alligator. That's kind of nifty. Whatever. Let's start with that. I can only probe so many at once anyway. Alright, so I'll show you what I'm doing here. So if I take the original controller, right set up this time. Plug this in here. Let me back the camera up in a second so you can see what I'm doing here. So I'm just plugging this in. Alright. Let's take old reliable here. This is my Craftsman. I miss Sears sometimes. Let's pick kind of a dark gray here for this. And it goes in on the that line. And I'll pick. Grab a white one, I guess. Maybe I'll make up some fresh cables here. So this, I'm on pin 1 here. So if you look at the truth table, you are in the way. Go away. Truth table here. So pin 1 on a DB9 is your direction pads. It's going to be down, left, left, upper, left. Basically, what uses that pin are the left directions, and then finally the keypads down here. So, okay, let's see if we can get this to work. I'll show you what I was looking at. Chimney crickets. Okay. Common, that. Straight up ohms. And then we're going to go from pin 5 is the common or return. And you can see shortly what I was talking about. So if we go here and then here, and this is more or less the left direction. Let's see. There you go. So it gets you we're at 1.4K, 1.4K. So it's pretty high. So this is basically going off the left direction. And like I said, if you look at the truth table, the clear, it also, for that left direction here, it also is this bottommost row here. So we press there. Okay, you got 1.4K, 1.4K. So it looks like everything for the left needs to be, for column 1, needs a 1.4K. No buttons are used, so let's write that down. Write it down. So C1, pin 1 needs 1 point. Let's double check. Where are we sitting at? 1.45K. See if my other meter agrees. Straight up ohms. Well, sometimes newer isn't better. Let's see. Why am I not getting continuity here, guys? Yeah. 1.48. I'm looking on the left here. 1.47. So real close. Okay. That's good. And then I'll do a couple more. So pin 2 does a lot as well. Pin 2 is all your up directions here. You can see upper right, right. And then you have it's basically your up is on here. Let's see what that looks like. I'll move you over to pin 2. Okay. So that's your upper directions. Let's see. $2.31K. Let's see what the keypad looks like. So on the keypad's K7, 8, and 9. 7. Same thing. 8 and 9. So they probably had a 2.2, be my guess. They probably had a 2.2 in there. And 1.14, probably a 1K. Resistance goes up as time gets older, so they probably did a 1K there. It's a nice standard value. wouldn't probably use a 2.31. You're probably picking up another 100 ohms off of the contact resistance. That makes sense. Talking to myself now. All right, let's go move over to pin 3. Pin 3. Again, I'm going to refer back to our truth table here. Pin 3 takes care of your right directions and the next row up. So let's see, right we're looking at. Maybe they are using the 1.2. Yeah. That's pin 2, pin 3. Looks like they have about 1.24. Maybe it's 1.247. And again, this is the next 1.16, 1.19, 1.0. So yeah, about 1.1. So 1.1 to 1.2. So somewhere in there. That's fine. All right, next one. Pin 4, which is, again, let's refer back to our truth table. Pin 4. We are looking at the down direction. Okay, I need to wrap up this video soon. If you ever hear that train going off, this is my wife calling me to bed. So, I'll turn my soldering iron off here. And that was pin 3. Pin 4 since this one. That was pin 4. Pin 4 was the... Pin 4 is the... Oh no. It's also 1.5. And pin 4 is the top row. A little lower on that side. It's weird. I wonder if I'm picking up another few hundred ohms off the... Yeah, so that's about 1.5. Except when you do the top row, and that's down at 1.03. So, except for pin 2, let me go back up, look at pin 2 real quick. That's interesting. Why would they vary it like that? 1, 2, okay, pin 2 there. Pin 2 is, oh, what? Pin 2 is the up. 2.1. Pin 2 is also K7. So it's definitely higher. So why is that one like twice the rest so far? I don't know. Well, we'll test the other one too, see if they both react the same way. So going over the pin 6 here. Pin 6 is your no directions, you can see here. So it doesn't do any directions here. And then it is K1, keyboard 1. Getting nothing out there. We can get in between there and see if we got something going on. It's so weird. Try it all the way over at K9. K9 is the weird. It's interesting. They did a column here for your. This is where the the true 16 is going to come into play. This column here is where the 16, where your other directions come from. All right, meter, what's up with you, man? Black water might have come out. That's why. Kind of need that one. That's the most important wire. The weird one is the one over on pin 9, which is where your directions come from. Your off directions. Kind of wild, so this should show up. I think my meter's gone cattywampus. Hold on. Oh, it's there. Let's go over here. What's up with you, man? Let's see. What is going on? Let's try pin 6. I'm getting slap happy. I'll have to figure this out tomorrow. But halfway there. Let's go back to 1 to see if that's not working. There's 1 I know was working. 1 is your ups. Okay, 1's working. Okay. These are your side buttons. Oh, there it is. There's one of your side buttons. That's way up at 30K. Wow. That is so weird. Let's try a different side button. There it is. Meg, 700K. That's weird. So the buttons seem to be what's coming on here are much higher. So I gotta figure out what's going on over here. So that is about 700K. Why is it so high? And then finally we have one pin. So pin 6 here. I should see one of the side buttons come up. Why am I not getting a good connection on that guy? Just pin 6 is messing with me. I'll have to figure that one out. Alright, everyone. I'm gonna get some sleep. I'm tired. Making mistakes. But close. We're getting closer. Let's figure what's going on. This looks like from 1 to 4 it varies. You have like 1, you get like 1K here, 2K, 1K, 1K, and then really high up in 6, 7, and 8. All up in like the 700K range. I'll emulate it. I'm gonna try out the other controller and then put it on mine. I might not be able to work on this till like Monday though. It's very early Sunday morning because I want to get some of those 5200 controllers built up, and then I'll come back to this. Interesting. All right, everyone. Thanks for watching. Have a happy Easter.